everyone. I'm Francesco MATONTI, working for HxGN Geosystem. Before to start, I would like to present how we bring the reference frame, international reference frame and the local regional frame to the end user. I would like to thank my colleague Joanna and Adam for helping preparing the presentation, but also I would like to thank all the team in Leica helping to develop and maintain the HxGN SmartNet network. Let's start, let's go back how we started the network. So as you know, the RTK service in the past, it was made with the base and rover, so the surveyor mainly were buying the base and rover, installing the base on a marker with the well-known coordinates, and then they were using the rover going around and connecting to the base station. We started to install from 2001 some permanent reference station for small projects, mainly in UK and in Italy. And at that time also our software, Leica, at that time it was called Leica GPS Spider, was ready. We started with to provide network correction, and at the end of 2005 we had the first big network in UK that we call the Leica SmartNet UK, and in the same time period we also had the same network in Italy, then we were still installing other permanent stations. We were growing, and we installed quite a lot of stations, and Leica Geosystem was also part of the HxGN group, and we renamed it, we recalled our network HxGN SmartNet as a global network. This is the actual coverage today. We have 5,300 GNSS stations around the world in 26 countries. We offer two types of service, NRTK and PP solution. So you see in blue the coverage with NRTK, and in green the coverage of the PP service. And PP we provide on mobile internet and also on L-band. What are the applications of the network? So we started with land surveying, and for them the use of local reference frame is a must. Then we started to have precision farming and machine control and other applications using our service. And actually for precision farming and machine control, there was a requirement to have an operational service working 24/7, 365 days. So we adapted our network to with the redundancy server to have always the service available. And then with the introduction of the positioning service in the automotive industry and other application, there was another requirement to have to use a global reference frame. That actually it was not possible in the past because we were divided per country, and then we were using always the national reference frame in each country, and this was a problem for the automotive industry. As you can see, this is just a representation of how this is Europe. Okay, you see the difference between the country. Each country has different ITRF realization with different epoch, and this is really a problem when you are crossing the country and you want to have unique reference frame. Before to show the solution that we adopted, I would like to tell you how we compute the coordinates of this 5,300 station. First of all, we have divided, since we are not able to compute all the stations in one run, we have divided in Europe, for example, we do the computation for each country separately, but we use a common set of IGS stations, and we use the Berlin software. Actually, we are using the Berlin software 5.4, and we are following the guidelines of the analysis center. And we generate daily coordinates solution and biweekly coordinates solution. Actually, our network is using the ITRF 2020 epoch 2024, 1st of April. Okay, then and these coordinates we use in our software to generate the network correction. Additionally, the software like HxGN SmartNet is able to manage also for each station different set of coordinates in different reference frame, and for this we also compute the coordinates in the regional, in the national reference frame. We use the transformation, the relation defined in the ITRF technical note, number 1, but sometimes we also use the, if available, the station of the national network, and we run the computation and compute the coordinates, and we validate our coordinates in different way. Let's go back to our issue, or our problem, or automotive problem. So let's say the single surveyor, you can see, is okay connecting to the unique, to the URL that we have available for the country. So he's connecting, and he will get the correction of the network in the reference frame of the country where he is. This is the same for other countries. But when we are talking with applications that are crossing border, this is a problem. So what we have, thanks to the software that we are using, we can also provide the ITRF 2020 coordinates, so the set of coordinates in the international reference frame, so they will not jump from one country to another one. They will not have any jump. And we are also providing a unique URL for them, so they don't need to switch between different URL. How we do that? So different people of users, they can connect to the same single access point. So we have just one single access point. They will send, they can select the mount point based on the application that on what they need. So they can select if they want to work in the international reference frame or in the local, in the regional reference frame. So when they connect to this single access point, they send also the position with the NMA and GGA, and our software is able to redirect to the corresponding region and deliver the correction and the reference frame required from the customer, the user, the end user. Yeah. And this is just the last slide where so we are also monitoring every day the position of our station around the globe, and this is just an example of we check every day the quality and if there are movements or any change